Alright, so the new unit we're going to be talking about is parallelograms, and your learning target is I can prove and apply properties of parallelograms to solve problems. So let's go through first a definition of what a parallelogram is. And a parallelogram is a four-sided figure with two pairs of, get this, parallel sides. Okay, so they're going to be parallel. That's your first blank right there. And we can see right here we have a parallelogram. The two sides, these two are parallel, and then these two are parallel. So this makes that a parallelogram. So there's four main theorems we're going to talk about today involving parallelograms. And the first one says that in parallelograms, opposite sides, that's your blank here, opposite sides are going to be congruent. That means when we're looking at like this parallelogram up here, AB is going to be congruent to CD, and BC, this top one, is going to be congruent to DA. The opposite sides are going to be congruent. Now also the opposite angles are going to be congruent. That means AC, this whole angle, is going to be congruent to this angle, or angle A is going to be congruent to angle C. And angle B is going to be congruent to angle D. Okay, so that second blank there, opposite angles are congruent. Thirdly, consecutive angles are supplementary. Okay, consecutive angles are supplementary. Consecutive means that the ones that are lying right next to each other. Okay, so C and D are consecutive angles, B and C are consecutive angles, B and A and D. Anything that is right next to each other, those are what we're talking about when we say consecutive angles. Okay, and then remember, supplementary means that two angles add up to be 180 degrees. That means angle A plus angle B is going to be 180. Angle B plus angle C is 180. C and D are 180, and then D and A are 180 degrees. Okay, and then the last little thing here is that diagonals bisect each other. Diagonals bisect each other. Okay, so if we were to cross the two sides, or the two angles here, Z is going to split this line, BZ and DZ, in half. So these two are going to be equal. And Z is also going to split AZ and CZ in half. So those are going to be equal. Okay, these are four very important theorems that you understand in order to help us solve these types of problems. So the key concept here, in order to solve problems using the properties of parallelograms, we're first going to need to identify and label the sides given if not already done. And then second, use the properties that we mentioned above and other geometric properties that we've talked about all year long in order to solve for the missing sides. So let's do an example here. Example 1 says that in parallelogram CDEF, we've got line DE is 74 millimeters. Remember, our first step here in the key concept said to label these sides if they weren't already. So DE is 74 millimeters. DG, this short little section right here, is 31 millimeters. And angle FCD is 42 degrees. So FCD, this whole big long thing, is going to be 42 degrees. Okay. Now what we want to find then, what it is asking us to find, is CF, the measure of angle EFC, and the measure of our side DF. Okay, so let's go ahead and let's solve those now. CF here, we see that this is CF, and we know something very special about parallelograms. That first theorem we talked about said that opposite sides are congruent to each other. So CF, line CF, is fairly simple to see. That's just going to be 74 millimeters. Okay. CF is 74 millimeters because the opposite sides, that first theorem, says they are congruent. Now this second one, we're trying to find the measure of angle EFC. EFC, we're trying to find this angle. And if we look back at our theorems on the other page, we saw that consecutive angles are supplementary. So these two angles are going to add up to be 180 degrees. So let's go ahead and write that down. We know that 42 degrees plus angle F, I'm just going to call that F, is going to be equal to 180 180 degrees, right? So these two angles added up is going to equal 180. Now it's just solving, so we're going to subtract 42 degrees from both sides. And we get angle F is equal to 138 degrees. Okay, and really we could write this as the measure of angle EFC or something like that. I'm going to go ahead and do that because that's kind of how it was written at the very beginning. That way we know really what angle we're talking about. Okay, and then this last one right here we needed to find was side DF. Okay, DF is this length right here. And this one we can use the last theorem. Okay, the last theorem said that diagonals bisect each other. That means that this side is going to be equal to this side. So DG is going to be equal to FG. Okay? DG is going to be equal to FG, and if we know that DG is equal to, or is 31 millimeters, that means DF must be equal to 31 plus 31, which adds up to be 62 millimeters. Okay? We know that's the case because if this is 31, then FG has to be 31. Add those two together, we get 62. Okay, example 2 says WXYZ is a parallelogram. We need to find the length of YZ and the measure of angle Z. Okay, so we've got YZ here, and that's A to A minus 4. And we know that's going to be equal to this length right here because we know about parallelograms is that the opposite sides are congruent. Okay, so all we have to do in order to find the length of YZ, that's going to be equal to these two are, well, we know these two are equal to each other, so we can set these two equal to each other and then solve, right? So we've got 6A plus 10 is equal to 8A minus 4. And now we just have algebra. Now we just have to solve for our A. So we're going to subtract 6A from both sides. We get 10 is equal to 2A minus 4. Solving for A here, so we're going to have to add 4 to both sides. And we get 14 is equal to 2A. And then divide by 2. And we see A must be equal to 7. Okay, that's not it. That just solved for A. And now we can plug that number back in for A and solve for ZY. Okay, or YZ. So we know YZ, again, is equal to 8A minus 4. And if A is 7, plug 7 in for A, then it's really easy to solve. 8 times 7 is 56 minus 4. That means YZ must be equal to 52. Okay? So YZ is equal to 52. Now we can just do the second one. The second one that we're trying to find is the measure of angle Z. And we know something very important about these two angles as well. We know that angle Z and angle W are consecutive angles, which means that they're going to add up to be 180 degrees. So let's go ahead and we're going to work that part over here. We know that 18B minus 11 plus 9B plus 2 is going to add up to be 180 degrees. So let's combine those like terms first. 18b plus 9b is 27b. And negative 11 plus 2 is just negative 9. That's going to equal 180. So we have to add 9 to both sides. We get 27b is equal to 189. Divide by 27. Divide by 27. And if you do that on a calculator, you're going to end up getting that b is equal to 7. If you needed to, get out your friend and check that. Now that is not, again, that is not our answer yet, because that only tells us what b is equal to. Now we have to plug that back into the equation for z. We know measure of angle z is equal to 9b plus 2. So we're going to plug 7 in for b. So 9 times 7 plus 2, which is just equal to 63 plus 2. So we find that the measure of angle z is equal to 65 degrees. Okay, so as you can see, a lot of this is just algebra, and it just uses a little bit of information of understanding what the properties of parallelograms are, and then you just solve. It's that easy.